You're on the grass, looking up at the blue sky, enjoying some singing birds and catching some rays. You watch different shaped clouds soaring slowly, high up in the air. Suddenly, you hear a powerful loud rumble coming from far away. You get up and notice a gigantic thick cloud ahead. But it's not the size that scares you, it's the shape. The cloud looks like a skull. Don't worry, it doesn't mean anything bad's gonna happen. Anyway, it's not even a cloud. A few years ago, a skull formed out of thick smoke over Mount Vesuvius in Italy. That's the same volcano that erased the ancient city of Pompeii from the face of the earth. Of course, back then, many people were afraid that the volcano would erupt again. Luckily for everyone, the volcano's still in a deep sleep. It was just a nearby forest fire that caused the famous skull cloud. But the locals weren't so sure. Some thought that the fire and the skull were set on purpose. Wouldn't be the first time. Centralia, Pennsylvania. Population, well, just look around. Looks a little scary. Bare trees, no animals, no people. All the buildings are empty. Roads are all cracked and strewn with gravel. No cars, obviously. Thick smoke everywhere. This town's been burning for more than 50 years. Centralia used to be a mining town. One of its coal mines was abandoned, and locals used it as a dump for their trash. Then, according to most people, the city decided to get rid of the trash in the usual way, by burning it. The plan was a major failure. Let's see what could have possibly gone wrong here. The trash fire got deep into the mine's tunnels, ignited the coal that's still down there, and has been burning steadily ever since. The level of carbon dioxide shot up, and they had to shut down the other mines nearby for safety. No one could stop the fire, and the underground flames spread beneath the city. Roads began to warm up, the soil went sour, and the streets slowly filled with smoke and smog. In 2017, there were only 5 people living there. Welcome to Abraham Lake in Canada. It's completely frozen. You step onto the transparent ice and look down at what lies beneath. No fish, just some mysterious frozen bubbles. They look like small clouds frozen in ice, or jellyfish who forgot to pack a winter jacket. There are thousands of these little bubbles made up of methane. But don't try to dig a hole in the ice to touch it. Methane is highly flammable. It's created by methane-producing bacteria that eats leaves, grass, insects, and any other organic stuff that gets into the lake. When the methane touches the frozen water, it turns into tens of thousands of frozen little balls. When the ice melts, they burst open and sizzle. If you lit a match over them at just the right moment, the lake would look kind of like an erupting volcano. Similar lakes can be found near some shores of the Arctic Ocean. There, the size of the bubbles can reach several times the size of hot air balloons. Beautiful for sure, but not exactly safe. The next shocking lake is in Indonesia, on the island of Java. You come to a majestic volcano overgrown with grass and trees. The volcano seems to be asleep, but smoke is pouring out of it. You, of course, climb to the summit. Exhausted, tired, sweaty, you're ready to cool off. Nice work, you made it to the top. You look into the mouth of the volcano. No boiling lava, just a beautiful, bright turquoise lake down there. It looks like an oasis. Perfect time for a refreshing dip. You run down and get ready to jump in. But that's not water, that's acid. Sulfurous gases get into the lake from under the volcano. The lake itself is full of metals. When the gases touch them, they form that beautiful turquoise acid. Better head back to the nearest village, rest, and come back at night when it's cooler. In the dark, the lake seems to grow. Right above it, you see light-filled exploding little clouds. The sulfurous gases rise out of the lake, combine with the air, and flash bright blue. Still, don't get too close. Up in the sky, underground, volcanoes, lakes? Time to head out to sea. You get on a yacht and sail off. It doesn't matter where, this next one happens all over the world. So, the sea is crystal clear and calm, there's no wind in your sails. Everything is so peaceful. Wait, what's that? You hear a loud noise. 2 seconds later, a huge wave, way taller than your mast, rises from the calm sea and hits your yacht. The ship manages to stay upright and the huge wave disappears. You just survived the attack of a rogue wave. Some scientists think it happens when the surface sea current smashes into a strong headwind. Others say it happens when warm and cold currents come up against each other. Another popular theory is wave interference, where small waves team up to form one monster one. Under certain conditions, waves get a sort of superpower. Out of all the waves in the area, there'll be one which sucks the energy out of all the others. When it's full, the wave spits it all out. Maybe that's why the wave's so strong, but only lasts an instant. What about clouds? Scary? Well, they can be, if they're huge thunderclouds, walls of gray and black blocking out the sun, the moon, and the stars. First, you're relaxing in your backyard. Then you see thunderclouds. Then you get thunderstorms, hail, floods, and even tornadoes. They're easy to spot thanks to their epic appearance. Thick, heavy, and dark. They can even sparkle inside because of lightning. That's one scary-looking cloud. But before you run away, let's see how it forms. Clouds are like roller coasters. Imagine you're a small drop of water hanging out with your friends in the ocean, waiting in line for the brand new ride that just opened up. It's time. You strap in. Nothing happens. Then you feel it. The roller coaster starts to go up, up, up. You can see all your droplet friends down there. They're so small. You keep rising, just waiting for the big whoosh. But nothing happens. Then you're so high up that you're in the clouds. It's not so scary up here, and there are loads of your friends. Nice. It's starting to get cold. You look around, it's happening to everyone. You're being turned into beautiful ice crystals, so shiny and pretty. The clouds filling up, getting kind of cramped with all those other water droplets. Still, what a peaceful, enjoyable, wow! The ride kicks back in and you start to free fall. Slowly at first, then faster and faster, thousands of your fellow drops falling back to earth, some holding on tight to the handrail, some laughing and waving their hands in the air. Woohoo! And splash! Still, I like the lightning ride better. That's one where they strap you in, you ride up, and then you play bumper cars way up in the clouds. The more times you bump into another water droplet, the more lightning you create. Now, not all lightning happens inside clouds. There's a rare phenomenon called a dirty thunderstorm. The lightning happens above a volcano. The most famous is in Japan. It erupts almost every day and spits black clouds high into the air. So, it's super scary volcano clouds, plus lightning. Whoa! Regular lightning happens during a storm when ice crystals bump into each other. In a dirty thunderstorm, bits of volcanic ash collide, create friction, and spark up the sky. Okay, better finish the journey with something safe and beautiful. No more cloud roller coasters, please. You're in the Atacama Desert in northern Chile, one of the driest places on Earth. But this desert has a beautiful secret. Every 3 to 5 years, flowers pop up out of nowhere. It's so famous, it's also called the flowering desert. Seeds lie around in the ground just waiting for some rain. When the desert gets enough water, about 200 types of flowers sprout up. The yellow sands of the Atacama turn purple, white, green, and pink. Ah, Kiev, you've been dreaming of getting here for years. Getting out your trusty camera, you start taking pictures of the cathedrals, aviation museum, and the Dnipro River, when, without warning, there's an enormous boom behind you. Turning around, you see something towering in the distance. It looks like a gigantic explosion. Uh-oh, time to leave fast! In June 2020, what the people of Kiev were looking at was an Anvil cloud, a rare storm formation in the sky. Forming when strong air currents carry water vapor upwards, the air expands and spreads out as it hits the bottom of the stratosphere. It pushes the dense cloud into the cool anvil shape you see, and sometimes it even gets to be a mushroom. Anvil clouds produce some of the most dangerous lightning of all storms, one that's called a bolt out of the blue. This lightning strike seems to magically come out of the blue sky with the storm being many miles away. This type of bolt comes from the top of the anvil and can be 10 times more powerful than a typical lightning strike. People got so frightened after witnessing a giant cloud just 60 miles away, thinking something terrible must have happened. The locals had pictures of the large billow on social media before officials could explain what was going on. Authorities managed to calm everyone's fears by informing them it was nothing more than a natural phenomenon, and a beautiful one at that. Before dissipating, these clouds typically stay in one area, regardless of how strong the wind is. Touring around the northern tip of Queensland, Australia, way away from those creepy crawlies, it's time to take a break and relax at the beach. Getting comfortable, you notice a great big shadow passes over you, then another, and yet another. Looking up, this weird weather is simply stunning. The clouds are called morning glory, a very rare type of cloud that almost seems to roll across the sky, looking like a massive tube. These clouds can measure up to 600 miles long, even appearing in large groups as well. This phenomenon is the result of an updraft pushing through the cloud, creating a rolling appearance, while moist cooler air at the back causes them to sink downward. Southern India, between July and September 2001, people witnessed one of the strangest weather phenomenon in recorded history. The rain was red. What many would have thought to be a typical rainstorm left them shocked. The color was bright enough to stain clothes. There were other colors too, such as green, yellow, brown, and even black. In the middle of a monsoon, red rain started to fall, and did so periodically for several weeks. Researchers have found this unusual rain is stained either by dust or algae, so don't try to catch any on your tongue. Scientists aren't entirely sure how the algae got all the way up there. This does make events like this a little unsettling. Like to take a bubble bath to relax after an exhausting day, but taking too long to fill the bathtub? Problem solved. Head to any coastline after a big storm and take a dip. Foamy tides aren't native to any one place or location. They can be formed anywhere in the world. They're most likely to happen along rocky coastlines, like the coast of San Francisco, Northern Ireland, or the Mululaba, Australia. Each coast has differing conditions forming the sea foams. If you scoop up seawater into a glass and look at it closely, you'll see it's full of tiny particles. Many things like plants, chemicals, and lots of salt and minerals create the perfect formula for foam. When powerful currents and wind mix it all together, we get something that resembles a cappuccino top floating on top of the water. When freezing temperatures hit orchards in Michigan, all kinds of unusual things happen, like ghost apples. No, they're not going to scare you at all. But if you plan on sneaking away one winter to find one, be warned. Everything has to be perfect for this to occur, and it's going to be freezing cold. This is actually a rare weather phenomenon caused by having the apples freeze where they are, with rain coating the fruit in a thin layer of ice. The apples then thaw and leak out like applesauce, leaving just the beautiful ice shell behind. The Catatumbo River in Venezuela might be the most electric place in the world, with nearly 300 storm days per year. The lightning storms are so consistent, they're predicted for 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute, a truly shocking experience. With each bolt having the energy to power a single light bulb for 6 months, the impressive display could power all of Venezuela forever. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. As the water droplets of humid air collide with ice crystals from the cold air, it produces the static charges that cause the lightning storms nearly every night. If that wasn't bad enough, some storms have lightning above them as well. Try to take a picture of this one. Jellyfish lightning sprites are electrical discharges high in Earth's atmosphere. They're associated with powerful thunderstorms, but they have nothing to do with rain. These sprites occur 30 to 50 miles up in the sky, in the mesosphere. Artificial lights at night make it a lot harder to see this faint lightning. If you spot one, it'll look tiny, but can be well over 30 miles wide. The red sprites are a type of cold plasma discharge above a thundercloud. They're the balance of the lightning charges between the storm clouds and the ground below. Don't try to find this type of donut at your favorite bakery. It won't be there. Snow donuts are one of the rarest meteorological sights to see, with perfect weather conditions needed just to create them. Found in any snow-covered mountain area, like the Rocky Mountains, the wind, temperature, snow, ice, and moisture have to all work together for us to see these phenomenal rings. A thin layer of wet snow on the ground. Under that layer, ice or powdered snow. Then, a strong enough breeze to roll the donut down a hill, just like a snowball. Once it stops rolling, it can be the size of a baseball or as large as a car tire. It all depends on how strong the wind is. A newly formed snow donut won't stay around for very long, so hurry up with that camera. Watching the sunset over the horizon, the beautiful purples and pink overhead are nothing compared to the 3 suns you see in front of you. Wow, since when did Earth get 3 suns? These phantom stars sometimes appearing beside the sun are called sun dogs. Maybe they're called that because they're kind of dogging the actual sun? Sundogs often appear as colored areas of light at the same height above the horizon as the sun. They're mostly observed on a ring or halo, where ice crystals best reflect the light. There are also moon dogs that appear alongside the moon and are formed by lunar light passing through ice crystals, though these aren't seen nearly as much as their daytime partners. Taking photos in the wild, you finally found the perfect spot to take that dream shot. The crystal clear water, the pines, the mountains, and the flying saucer. Wait, a flying saucer? Oh, aliens are here! You might be thinking this if you saw a saucer-shaped cloud. I'm not even going to try to pronounce their name though. Put that on the screen, please. Wait, just kidding. It's altocumulus lenticularis. Aren't you impressed? These are really just unusual cloud formations over mountaintops. When moist air flows over a mountain, a wave is created if the temperature difference is perfect. As the air passes through the wave, evaporation occurs and a series of these clouds may form into an oval shape. Not aliens at all. Whew! The sky is falling! The sky is falling! Well, people who have experienced these clouds say they look like they're coming down from the sky. Mammitous clouds look like giant white lumpy marshmallows, but it might be hard to toast these ones. These weird fluffy clouds can extend hundreds of miles in any direction, remaining visible for short periods at the bottom of Anvil or other thunderstorm clouds. The strange bubble shapes are formed from turbulence within the storm itself, creating an uneven cloud base and appearing anywhere in the world. Mammitous clouds form when moist air sinks into dry air. The air must be cooler than its surroundings, cooled with ice, or be heavy with water. Hey, what's wrong with that plane? It's flying over your head, moving in circles. Has it lost its way? Are there some problems with its navigation systems? Nah, calm down. It's just sprinkling salt over the clouds. It's called cloud seeding. Now, I know for sure rock salt is used to prevent people from slipping and cars from skidding off the road in winter. But why would we need to do it in the sky? Well, drought is a big problem in many places all over the planet. A lack of drinking water, parched soil, wilting plants, and cloud seeding could solve this problem once and for all. To put it simply, the whole process is sowing clouds with chemicals to make it snow or rain. Different stuff is used in this process. For example, bright yellow silver iodide, dry ice, and even common table salt. They mix with the clouds and thicken them. The larger the clouds are, the more likely it'll rain or snow. It goes like this. Water evaporates and rises into the atmosphere in its gas form. There, it cools down and forms into clouds. The bigger and heavier water droplets become, the sooner they fall down to Earth. Cloud seeding helps to speed up these droplets' growth. Planes either shoot the chemicals into the clouds or release them while flying nearby. Sometimes the seeding is even done from the ground. Scientists claim that when the atmosphere is clean, the chances it'll rain after some cloud seeding increase by 30 to 35%. If the atmosphere is dirty, though, this number is lower, just 10 to 15%. And still, some people are skeptical about the cloud seeding idea. They're sure this method works only on the clouds that would rain anyway. But if cloud seeding does work, lots of regions with little water or regular droughts will be literally saved. Even the driest places have some water in the air. Once you manage to pull it from there, voila! You can create rainfalls. There's another thing cloud seeding can help with, and that's hail. In some areas, a single hailstorm can cause up to $500 million in damage. That's why specially modified planes fearlessly enter storms and spray chemicals into the clouds. This reduces hailstone size. Plus, if they're in time, the planes prevent small cloud towers from growing into huge mature hailstorms. Ever noticed white trails airplanes leave in their wake? Those are called contrails. They appear when humid emissions from jet engines mix with the atmosphere. It's much colder and has lower pressure than the exhaust gases. The water vapor they contain condenses and freezes. This forms a cloud, like the one your breath makes on a cold day. Contrails can have different thicknesses. They can stay in the sky for hours or disappear after several minutes. They can stretch for miles or they can be rather short. Everything depends on the altitude and the humidity and temperature up there. Look at a contrail attentively and you might be able to predict the weather. If the contrail's thin and short-lived, the air at high altitudes is dry, it's not going to rain, and the weather's going to be just fine. But if you see a thick contrail that stays in the air for a long time, bring along your umbrella. The air is humid high above your head. It's an early sign of an upcoming storm. The average passenger aircraft reaches its cruising altitude of 6 to 7 miles in the first 10 minutes of flight. But how high a plane flies still depends on its weight and some other characteristics. For example, the famous supersonic passenger airliner Concorde. Its greatest speed was twice faster than the speed of sound, and it used to fly way higher than other modern-day planes, at 50,000 to 60,000 feet. But this plane was the exception rather than the rule. By flying at such a height, planes can avoid bad weather. High winds and heavy rains often occur in the lower layers of the atmosphere. Also, keeping to high altitudes allows planes to stay clear of heavy air traffic, for example, helicopters and light aircraft. Birds and even big insects don't bother you during the flight too. And if an emergency happens at a height of more than 6 miles, pilots will have more time to figure out the best possible solution. Why can't commercial airliners fly higher than 38,000 feet? Well, it's not that they can't, they simply don't. Because if they did, there would be serious safety issues. First of all, if a plane is flying that high, it needs more time to get back to a safe altitude. And during an emergency, like rapid decompression, every second counts. At lower altitudes, airliners can also rely on the wind. If they rise too high, they'll waste too much fuel to stay in the air. While traveling at such a great height, planes can't communicate with the ground surfaces as well as they do when flying lower. Once a plane climbs too high, the air can't provide enough lift to keep the machine going. The lift is created by the difference in air pressure, but at high altitudes, this difference is too small. Air may not look like something real because it's nothing like metal or plastic, and still, it's one of the things that keeps planes aloft. Let's say a plane is heading for space. It has large, cleverly designed wings and super powerful engines. But the higher it goes, the thinner the air becomes, until there's hardly any air left. And then nothing can help the plane go further since there is a near vacuum around. That's why we still need rockets to get to space. And finally, planes don't fly too high because they're a bit too heavy. The more a machine weighs, the more difficult it is to bring it to a certain altitude. Planes don't take off when the weather is too hot. For one thing, jet engines don't like extreme temperatures. A much bigger problem with scorching temperatures is that aircraft just can't generate enough lift to rise into the air. And, as you already know, if there's no lift, there's no flight. To generate this lift, the air around the plane should be dense enough. But the hotter the air is, the less dense it becomes. When the temperature rises, air molecules heat up and start to move faster. They're also moving apart, creating more in-between space. This results in low air density. The wings don't have enough stuff to push against, and they're unable to produce the necessary lift. The highest temperature at which a plane can take off or land depends on the aircraft, runway length, payload, and airport altitude. In most cases, it's 110 to 125 degrees Fahrenheit. Airplanes can fly through hurricanes, and those are less dangerous to flights than thunderstorms. But why? The most catastrophic hurricanes can travel thousands of miles, and their effects can linger for days afterwards. Most hurricanes form at a much lower altitude than thunderstorms. That's why a plane can easily fly over certain parts of a hurricane. Of course, no commercial airliner will ever go through the eye wall of a hurricane. There, the winds are the most powerful. But while flying farther away from the center of a hurricane, planes are in no danger. As for a thunderstorm, it can create gigantic cloud structures. Their tops can reach more than 60,000 feet. That's almost twice higher than the average cruising altitude of commercial airplanes. So, when an airplane comes across a thunderstorm, pilots either try to find a roundabout route or simply turn back. If possible, planes avoid flying over very high mountains like Everest. Imagine that a plane starts to lose cabin pressure while moving over the Himalayas. Maybe one of the doors was sealed incorrectly, or there's a crack in a window or the fuselage. The passengers and crew members put on their oxygen masks, but this oxygen is going to run out in 15 to 20 minutes. At an altitude of 35,000 feet, it's a disaster. That's why pilots have to make the plane drop down to 10,000 feet. There, the passengers will be able to breathe without using oxygen masks. But the plane is still moving over the Himalayas, where many peaks are taller than 25,000 feet. In other words, the plane has nowhere to go. Another reason why planes have such an impressive cruising altitude, it allows pilots to have some room for error. If something goes wrong with the engines, the captain can glide the aircraft while trying to fix the problem. Unfortunately, even the most experienced pilot can't do much if there's a mere 6,000 feet down to the mountain slope. Let's say something happens to a plane and an emergency landing is unavoidable. Then pilots might have problems with finding an airport in the mountains. If we talk about the Himalayas, Kathmandu Airport can deal with a jet. But this place has only one runway and doesn't have an instrumental landing system. Plus, if you've ever flown over the mountains, you must know that the turbulence up there is quite nasty. Winds move over high mountain ranges at breakneck speeds and create so-called mountain waves. And while turbulence isn't dangerous per se, airlines still try to plan their routes around mountainous areas.